Hello everybody, this is Dr. Noor Badsha. Today lecture is about data visualization. In last lecture we discussed about organization of data, and then we talked about sampling techniques. Now the next lecture, this lecture is all about how to visualize data, mean to say how to draw those data. Now why data visualization is important? So you know that our eyes are basically drawn to colors and a pattern that's more attractive to us. So geometrical or graphical representation of organized data is used to analyze, clarify, and interpret numerical data functions and other qualitative structures. Okay, so it also provides excellent way for researcher to present data to non-technical audiences without any confusion. What are the advantages? So from a graphical representation of data, one can quickly identify, differentiate between two different quantities. Like you can identify red from blue or squares from circles. It's very easy to do that by using geometrical representation of given data. This is another form of visual art that grabs our interests and keep our eyes on the message. Okay, easily sharing information, and a lot of people obviously they can get many information from one figure, or you can represent a lot of information by one figure simply. Interactively explore opportunities, and it visualizes patterns and relationships in the data as well. Disadvantages are the visualization is just designed wrong, so that it's biased or confusing as well, and it is biased or inaccurate information you can get from that, and maybe core message can get lost in translation. So these are the well-known graphs which are used in statistics. We usually talk about histogram, which are mainly important for quantitative data. The frequency polygon, the ogive or cumulative frequency graphs. All these three types of graphs can be used for quantitative data, whereas the other graphs can be used for qualitative data as well. The bar graph, the Pareto chart, the time series graph, we do talk about the pie graph, and we talk about stems and leaf graphs as well. There are many other graphs as well. We'll be talking about them accordingly whenever they are required. So first we talk about histogram. So the histogram is the graphical representation of continuous data through contiguous vertical bars whose heights are usually determined by their frequency, and the horizontal axis usually display the class boundaries. Mean to say, it's important for histogram to introduce class boundaries first. We don't use class limits in case of histogram. And the vertical axes are usually used for frequency, and the width and height of each bar that would be determined by using class width and by using frequency of the class respectively. That means the width of the rectangle, the rectangles, the bars which are used for the which are used in histogram. So the width is computed by the class width, determined by the class width, whereas the frequencies of the classes will be used to determine the height of each bar. Let's do an example. Let's suppose we consider the following data, which is the highest temperature in degree Fahrenheit for 50 different states. Let's talk about the construction of histogram. What are the main steps to construct a histogram? So the first step, let's suppose the data. The class limits are given 100 to 104, and the frequency is 2, and so on. You can have any type of data. So the first step is you need to introduce class boundaries first. Okay, and you know how to introduce class boundaries. If you have integer data, so in that case the class boundaries could be like subtracting 0.5 from here and adding 0.5 to this one, and similarly 0.5 here and 0.5 here, subtracting from the left limit and adding to the right limit. So we have these class class boundaries. Now what do? We have to take these class boundaries along the x-axis, whereas the frequencies will be taken along y-axis, and then we simply join them by using bars. Okay. So the histogram for this specific data could be seen in this way. You see that we have first a lower boundary of this class is 99.5. So we start from 99.5 and going up to 104.5. The next one is here, the next one is here, and you see that the frequency of the first group, that is 2. So the height of the bar will be 2. So you see that its scale is 2. The next one is 8. The next one is then 18. The next is then 13, 7, and then we have 1, 1. So this is the histogram, which obviously represent the behavior, the data, and you can see from here the maximum number or the maximum temperature that will be between 109 to 114.5, and that is in most of the towns or most of the states. Okay, we can use frequency polygons as well for presentation of data, for visualization of data. It's clear from the name we will be using frequencies and we'll be constructing polygon as well. In this case, what do? We basically plot the frequencies against the midpoints of each classes. You would first find the midpoints, and then you plot midpoints against the frequencies of each class, and then you simply plot them or join the points through line segments. Okay, that's an example for the same data as we did a bit earlier. So we want to construct frequency polygon for that data, the same data, you see 100 to 104. In this case, we don't need to introduce class boundaries. We would simply find the midpoint of each class. The midpoint can be found as upper limit plus lower limit divided by 2. That's 100 plus 104 divided by 2. That's a one class midpoint. The next class midpoint will be simply 105 plus 109 divided by 2. So we can have this one. Another way, if you find the first midpoint, then the remaining midpoints can be found by arithmetically by adding the class width. The class width in this case is 5, so we can simply add 5 to it. 102 plus 5, that is 107, then plus 5 is 112, and so on. Now we take these midpoints along x-axis, whereas the frequencies will be taken along y-axis, and then we plot them together. For 102, you have to have a dot at 2, so we can have a polygon like that. Whereas for less than 100, we will simply have frequency 0, and after 132, the frequency will be 0 as well. So we can simply join those points through line segments to get this frequency polygon. It's also obviously it can be used for data visualization. Another graph that is the ogive, or we may call it cumulative frequency graph. In this case, what do? We basically plot the right and boundaries of each class, right, against their corresponding cumulative frequencies, and then we join them through line segments. Okay, so the class boundaries are taken on x-axis. Keeping in mind, we have to use class boundaries as we discussed in histogram. So the class boundaries will be taken on x-axis, whereas the cumulative frequencies will be taken on y-axis. Instead of frequencies, we now consider cumulative frequencies, and then we simply plot them, right, plotting each cumulative frequency on the right boundary of the classes. Okay, and then you have to join those points through line segments. That's an example, the same example what we discussed earlier, but now we want to construct ogive for that data. So in this case, you need to introduce class boundaries first if it is not given, because it's important to have class boundaries, and will be cumulative frequencies will be plotted against the right end of each class. Okay, so yeah, the cumulative frequencies are what you know how to find them. The first one is 2, the next one is then obviously 2 plus 8, that is 10. Then we have 10 plus 18 to get 28, 28 plus 13 to get 41, plus 7 is 48, and then 47 plus 1, that gives you 49, 49 plus 1, that is 50. So the last cumulative frequency should be the same as the total frequency. Okay, so now what do? We simply plot all these points. As I said, for the right end of the class boundary, or the right boundary, you see, we have to put this cumulative frequency. So the first class has frequency 2, cumulative frequency 2. The second one has 10, the next is 28, and so on. And now you join all these together through a straight line segment to get this is the ogive for the given data. You have to join them through straight lines line segments. Okay, there are some more graphs as well, which are obviously most of them are used for qualitative data, because these three graphs cannot be used for qualitative data, whereas bar graph can be used for qualitative data. So keeping in mind that's different from a histogram, because histogram is used for quantitative data, whereas this graph is used for qualitative, or you may call that categorical data. Okay. A bar graph represents obviously the data by using vertical or horizontal bars. In this case, we can have either vertical bars or horizontal bars, and the height or length. If you are having vertical bars, there should be height of the bars, and if you are having horizontal bars, there will be a length of the bar. They are represented by, they are determined by the frequencies. Okay, and obviously the bars will not be contiguous as what we did in case of histogram. Okay. So let's talk about some data. The table shows the average money spent by the first year college students. We need to draw horizontal and vertical bar for this data. So for electronics, they are spending $728, and similarly for down decor, and for clothing, and for shoes. So the corresponding graph will be what? That's the horizontal one. You will take for horizontal bar graph, you will be taking these qualitative variables or categorical variables along y-axis, whereas their frequencies will be taken along x-axis, and then we simply plot them. Where in case of vertical graph, these variables will be taken along x-axis, whereas the frequencies will be taken along y-axis. Right. So you see these lines are, these bars are not contiguous, but keeping in mind to have you see the width of each bar should be same as well. The next is known as Pareto chart. Pareto chart is also consists of bars, but it is different from histogram as well as different from Pareto chart as well. Okay, in Pareto chart, what do? We need to this is used for obviously the same as what we had in case of bar graph. It can be used for qualitative or categorical data. Okay, and it can be used for representation of data as well. So in this case, the first step is what? You need to arrange the given data first from higher values to lower value based on the frequencies. Okay, so looking at the frequencies, the highest frequency, then the next frequency, then the next frequency, and so on. So you have to arrange the frequencies in descending order from highest to lowest. Okay, and then obviously you have to use those bars. The variables will be taken along x-axis, where the frequencies will then be taken along y-axis. Let's do an example. Let's suppose this is the data which are the homeless people for a certain cities. So in Atlanta there were 6,832 people are homeless, and so on. So the first step is what? You have to arrange this data in descending order. You have to take the maximum value at the top. So this is the maximum. The next frequency is this one. The next is this one. Then we take this one, and then we take this one, to have something like that. Okay, so right. So once you have arranged the data in descending order from highest to smallest, then we simply take the variables along x-axis and the values along y-axis, frequencies along y-axis. And keeping in mind that these bars are also will also be contiguous. So they will be connected to each other. The size of each bar, again, that would remain same. It's obviously not fixed, but it will remain the same. Okay, the next type of graph used in data representation or data visualization, that is known as time series graph. So it's clear from the name that this type of graphs are usually used for data which occur over a specific period of time, when time is involved. Okay, so for example, the number of homicides that occurred in the workplace for these 2 years, from 2003 to 2008, and that is given in the following tables. For 2003, the data was 632. So simply plot these 2 points together. You may take these values along x-axis, whereas the frequency will be taken along y-axis, and then we join those dots through straight lines. For 2003, there were something 632 homicides. So you see that simply take a dot here, okay, for 2003, then for 2004, and then join all those dots through line segments. So this type of graph is then known as a time series graph. Okay, the next one is the pie graph. So pie graph is also used to represent the data, and we represent this data in circles. Okay, so the circle will be obviously divided into different sections or wedges according to the percentage of frequencies in each category. Okay, for example, there is a data given, okay, for a certain Super Bowl competition. These are the foods consumed, or these are the foods eaten during this competition. So potato chips were taken or were consumed as 11.2 million pounds. The same thing for tortilla chips, they were 8.2 million, and so on. So what do we do? The process in this case, you have to do 2 types of computation, because in circle the total angle is 360. So we will divide that 360 angle into different parts. In how many parts? 1, 2, 3, 4, 5. So you have to divide that into 5 parts according to their frequency. So what do? We simply compute an angle for this one, for this part, that is 11.2 divided by 30 multiplied by 360. That would give you the angle for this sector, or for this wedge or this section. For the next one, it will be 8.2 divided by 30 multiplied by 360. From here we get the angles. Keeping in mind, we don't mention angles in the pie chart or pie graph. We use percentage. So you have to represent the percentages in the pie graph, and that should be plotted in circles. So how do we do that? Let's suppose we need to find obviously the angles. So 134 degree angle is obviously for potatoes, and then 98 degree, 52 degree, and so on. And also we compute the averages as well, percentage as well, sorry. So percentage will be computed as simply replace this 360 with 100 to get percentage. So for potato chips, we are having what? That is 11.2 by 30 multiplied by 100, that gives you 37.3%. The next one will be 27.3%, and so on. So you know how to find these percentages, and then we draw a circle, and then we put all. Obviously, you can have, let's suppose this is our initial line. You can just a reference line, you can call it, and then we draw an angle of 134 degree from here. That's the next line, and then you would write this percentage here, not this angle 134 here. Then the next angle will be this one, the next angle will be this one, the next one will be this one, and then we'll be left obviously with the last one, which is something 8.3%. Okay, that's the way to construct pie chart when the data is given. Okay, the next plot, they are known as stem and leaf plots, and in this case, how do we do that? What do we do that? It is basically used for data organization. Okay, that basically organize the data in a proper way. It's not like exactly geometry. It is represented by using some numbers. You know that every number has 2 types of digits. One will be considered as leading digits, where the other one will be considered as a trailing digit. For example, the number 13, it has 1 to be the leading digit, where 3 is what? That is the trailing digit. Okay, so in stem and leaf graph, what do? This is obviously used for organization of data, and it is a combination of sorting and graphing. It has the advantage over a grouped frequency distribution of retaining the actual data while showing them in graphical form. A stem and leaf plot is a data plot that uses part of the data value as the stem, whereas part of the data value as the leaf to form groups or classes. It is obviously used for counting or finding frequency for a certain group or for certain observations. Now, how do we do that? Let's suppose we have this data. I'm explaining the process with example. Let's suppose these are the marks obtained by 30 students in an examination, and we want to have, you see, these are numbers. 63 is number, is a 2-digit number. So in 2-digit number, this 6 will be considered as a stem, where 3 will be considered as a leaf. What are the other leaves for 6 in this particular data? So 6 is the as I said, is a stem. So one leaf is 3, whereas the other leaf will be 1, the other leaf will be 5, the other leaf will be 9, and so on. Okay, so these are the leaves, whereas the first digit will be considered as the as their stems. So we need to find obviously stem diagram for ist. So that's the proper way. You have to draw a vertical line. On the left side of the vertical line, we will be taking the leading digits, which are known as stems, whereas the right side will be used for will be basically filled by what? By the leaves of every number. So in this case, you see that our stems are 4. You see, if you have a number with 4, so we have 40, right? So there are some numbers for 4 as well. So 4 is the stem, then 5, 6, 7, 8, these are the stems, and then we go in this data in turn to check what are the leaves for every number. Now you have to go through the marks in turn and put in the units, figures of each mark in the proper row, right? And they are then known as leaves. For example, the first digit is 6, so 6 is here, and the corresponding leaf will be what? That will be 3. Whereas for the next one, 58, so 8 will come over there. Then we have 61, so 1 will come over there. And proceeding in similar way, what would happen? We will be getting something like that. So this is known as stem and leaf graph for this specific data. Okay, you may introduce a key as well, just to represent, just to show what have you done. So that can be done in this way. See, 5/2, that basically means 52. That means 4/0 will be 40, 4, 44, 47, 49, 52, and so on. So sometimes we also add key in it as well. In most of the cases, obviously, we do that just to tell what does that stem and leaf graph diagram represent. Okay, let's do some more example. What would happen if we have decimal number data, right, or a 3 digits number data, or maybe 2 digits with the decimal points, or 3 digits with a simple decimal point. So how do we do all those numbers? So the first example is, you see, it is obviously 2-digit numbers, which is discussed a bit earlier. So it's very simple to everybody, and then you have to introduce the key as well. What is the key you have used? So in this case, obviously the starting number is presumably 3. So we can, I know it's 2 is also there, so you can start from 2. Whereas in this case, you see the decimal points are what? You will take these numbers 8, 2, 9, 7, and so on. They will be considered as stem, whereas the numbers behind or after decimal point will be considered as leaves. So we have something like that. So see the digits, these are the what? These are the stem, where these are the leaf, whereas the key will be taken as 2 lines with 7, that is 27. Whereas the same thing here, when we are given to 8/5, in this case, in this specific data, that would mean 8.5. Okay, if we have 3-digit number with a decimal point, right? So you see 48.3. In this case, what do we do? 48 will be considered. These are the leading digits. So these will be considered as or a step, whereas the numbers behind or after decimal point will be considered as leaf. So and the same thing for 3-digit numbers. In this case, 52, 36, 70,
34, 83, these will be considered as our leading digits, and the next 3904 will be considered as trailing digits. So the output would be like that. We have 25, the starting, it's not important to have the numbers in a particular order. You can have different orders as well. So 25, and you see that 25.6, so 25 is the stem, whereas 6 is the leaf. We have 38 has 38.9, 38.5, we have 38.7, and we have 38, so that means 38.0, so there is a 0 leaf as well. The same thing here. So 52 we are having here, so 52, 3 is here, then we have for 52 this is 8 as well, and for 52 there is 6 as well. So these are the leaves for 52, and so on. In this case, the key is what, that is 48 slash 3, that basically means 48.3, whereas 36 slash 9, that would mean 369. So that's the key which represent basically whether you have decimal point numbers, or you have decimal numbers, or you have integers, etc. So that same can be extended towards 4-digit numbers as well. The same can be extended towards 2 decimal place number as well. For example, if you have 48.36, so 48.3 will be considered as its stem, and 6 will be considered as its leaf, and so on. I hope you got all these questions. There are many more techniques or graphing techniques, or we can visualize data by using many type of graphs. We are having box plots as well, we are having a scatter diagram as well, but they will be discussed once they are required in some topics or in some lectures. I hope you would learn something from this lecture. This lecture will be useful for you, and expect that you will share this with your friends, because spreading knowledge is also a good thing, and it must be done. Thank you very much for watching. Please share the video and subscribe the channel. Thank you very much.